Get ready because the shipping industry is ripe for disruption. You're listening to Autonomous Ships Headquarters Podcast with your host, JP.
Everybody, welcome to Autonomous Ships Headquarters Podcast. The goal of this podcast is to introduce you to people and companies behind digital revolution that is transforming the shipping industry. I'm your host, Juraj Pavlica, or more easily just JP, and today's guest is the founder and CEO of the company that developed from ground up several different autonomous aerial and surface vehicles. With his background in maritime cybernetics and controls engineering, he was developing aerial drone technologies before pivoting into maritime surface vehicles. Today, their SUVs, or unmanned surface vehicles, are advanced multipurpose sensor platforms that are mainly used for various hydrographical surveys. From building a high-tech startup, over pivoting and adapting to customers' needs, to patenting their technology and building one of the most recognized brands on the SUV market, he and his team has done it all. So, without further ado, please meet Vegard Evjen Hovstein from Norwegian company Maritime Robotics. Hello, Vegard. Welcome to the show.
Thank you very much. A pleasure.
Yeah. Why don't you tell us for the beginning, who are you and how you ended up here where you are?
Yes, my name is Vegard Evjen Hovstein. I'm the managing director of Maritime Robotics. And my background comes from what we, at least in Norway, call marine cybernetics or control engineering. Basically, it's about navigation systems, autopilots, how to control dynamic moving objects, vessels, robots, etc. So I was very thrilled about the kind of the technology that lies behind controlling big vehicles, so to say, and that inspired me very much also into actually at the same time then the early days of the drone revolution came in, mainly being unmanned aerial vehicles when I graduated around the year 2000, and I actually also had a master degree in autopilot systems for a rather visionary type of unmanned aircraft, unmanned aerial vehicle. How should I say?
You graduated from NTNU, right?
That's right. In around the millennium generation, and then I out of that I moved into a small startup company with some very experienced and motivating colleagues. Also working with the autopilot systems, drone technology, gradually moving into helicopter, drones, etc. But we were far too early, at least in our corner of the world, and that startup kind of went in a little bit different directions. But I moved back to my university city, Trondheim, then, and started Maritime Robotics in 2005.
All right. And what was the reason of founding this company? Like, what was the opportunity that showed itself, or what was the problem that needed to be solved?
I think I still had a big faith in both the UAVs, a strong motivation for that. Also, technology-wise, I think you need to be a little bit technology opportunist to get into. I will sometimes say that maybe the most important qualifications or skills is to be naive and stubborn. And if you have those things, I think you can get a long way. So you need to be a little bit naive. We were definitely still far too early. But I also had started to think about as mainly also shaped a little bit by Norway being a very maritime nation, I saw that why can't these kind of drone control systems, which were really then still my focus, the control loops, be used for a floating vehicle or a boat.
Yeah.
And at the time of starting Maritime Robotics, we started seeing that the framework for kind of using and then also, of course, developing this were better in Norway than flying things. We are, in a way, per definition, at least, it's been politically declared that we are not an aerospace nation, but we are definitely a maritime nation.
Yeah.
So, of course, some of the research program partners, international marketing experience, capabilities, everything was much more rigged, if I should say it that way, to go on the surface. So we literally took, for at least a few years then, we put our friends with wings on the shelf and focused everything on unmanned boats. And we had our first sailing unmanned surface vehicles back in 2006, I think it was.
All right.
And the first generation of what the USV platform that we still have, the Mariner, was about 2007 or 8. I don't recall right now, but around there.
Yeah, but over the years, as you said, you developed quite extensive range of technologies. It's very impressive because you're offering unmanned aircraft systems, you're offering moored balloon systems, and also unmanned surface vehicles. So could you tell us a little bit about this?
I think it's been happening a little. I thought about naivety and also, for example, a good business strategist would probably have asked us to kind of stayed focused, and I think we were too early. Looking back in retrospective, we were too early with everything mostly, and also that has created us to kind of always search for another foot to lean on if times got hard. So historically, we started with the drones, then we focused more on the USVs, which we actually climbed pretty well on. And then we had especially one big customer that came to us and said, yes, we really like your USVs, but we want this moored balloon system attached to your USV. And then we said, we don't really do this. And but he came up with a very interesting project in many ways, and not at least an interesting market. And then we say, okay, the technology is relevant, it's similar, so why don't we do that? Why not? So that's a little bit the history.
Very interesting story. And these systems that you develop, do you rent them or do you sell them? What kind of options are you offering?
Yeah, we do both. And the customer is always right, so we try to adapt this a little bit. But basically, we are a system supplier company. That means that our standard business model will be to deliver the product or the system, which is sometimes it is the product is the system, and offer a training package and after sales support in terms of spare parts, other maintenance, etc. Yeah.
All right. Very interesting. How big is Maritime Robotics in terms of people?
Yeah, so we just passed 25, I think now before Christmas. So we are growing pretty steadily. So I expect us to pass about 30 people.
All right.
Pretty soon.
Right. And what would you say is the vision of the company? Where are your aims at?
Yeah, I think we really see that also the brand in a way is pretty well positioned to become an international supplier of these kind of products, unmanned products for or unmanned vehicle systems for maritime operations typically, and we need to be internationally present, no doubt, and if we want to have that role, we also need to grow the company. In that order, mainly, it's we need to be internationally present to be one of those 5 to 10 best companies in the business, and thereafter comes the needed growth, really.
Yeah. Now, when you mentioned the brand, I also saw that you got a design award, and I must say that your brand looks quite visually impressive compared to the others on the market. So congratulations on having this done like this.
Thank you very much. It's been something we always kept in mind to keep. It needs to look good, things to be attractive, and we have always had our own designers in house, and try to keep that try to keep the design and the appearance up to good standards. But we have a lot to improve on.
Great. Yeah, let's dive a little bit deeper into technology, mainly for unmanned surface vehicles. So I'd like to talk a little bit about the Mariner. That is your flagship product in this branch, I would say. It's almost 6 meters long, 150 horsepower engine. It's quite a fascinating machine. And could you tell us more about it?
Yeah, as I said, we had the first, you could say, prototype of it back in 2007. I did this probably 7, but the current one is also designed in 2011. Yep, 11, and it was actually designed in close cooperation with one of the major seismic exploration companies in the world. It's called Petroleum Geophysical, or PGS in short terms. And the basic thing for that Mariner was to do support in terms of seismic operations. Go forward the seismic ship and measure different variables in the sea, look out for debris in the sea, maybe do a little bit of transfer of spare parts cargo between the ships that are in the operation. A long list really of potential application, and that is probably been always our sometimes the headache also, because you can really do you can really do so much different with these vehicles that but you need to start somewhere as well. So I think multi-purpose is also what we say about the Mariner. It's a multi-purpose sensor platform, and but it's been mostly in terms of these, you can say, offshore work-related applications.
Like bathymetry, geophysical surveys, those sort of things.
Yeah, but I think I would like to speak especially about, which I'm also going to come back later on, another product, but we could, what we call Bathymetric Survey, because I think that was always something that was tempting to us, because we compared it a little bit to the civilian robots. I would say that that has grown popular, and I would compare it to a lawn mower or a vacuum cleaner. And there's a lot of oceans and maritime surface in the world, and to build up a good 3D model of that is in many parts of the world not done, for the first thing, and it's very time consuming. So we visioned then if a robot can do that automatically, just as with your lawnmower, that would be a very attractive thing. Removing
humans from tedious and boring and risky work.
Exactly.
And I've seen that you also patented formation control technology, which is, I think, perfect thing that you need for those sort of projects that you just mentioned.
Yeah, exactly, and spot on observation from you also, and that was also, I think, the behind the reason why we started with this formation was probably more out of technology curiosity. We thought it was cool. And then we, of course, saw that, yes, we could, by this technology, distribute sensors in a large area in a simultaneous operation. And we saw bathymetry as just being one of the applications that can be done. And it still is just one of the applications that can be done. But it's a very attractive way of using that patented technology. You're right.
Definitely. And but can you tell us a bit more how it actually works? Does it work like some sort of a master-slave configuration that it follows the master ship and the rest of the vehicles remain in a certain formation? Or
yeah. So usually you're exactly right. It's we define a master ship because we think, at least in the foreseeable future, there will always be a manned ship in these kind of operations. So let's say you're doing multi-beam or bathymetry by multi-beam echo sounders. You could have the same manning as you have on your manned survey ship, but you have one guy that has a duty to follow, to control or monitor the unmanned boat or boats that is on the side. So the unmanned boats will then be acting as force multipliers. So the thing is that the master-slave concept makes that the unmanned vehicle doesn't have any a priori information about what's going to happen next. They just need to follow the geometric shape that they have been commanded to keep.
Yeah.
So
can I'm sorry. Go ahead.
Yeah, so the shape, the geometrical shape you would like it to follow, can be changed by the commander. And one more thing, we also have for seabed mapping, we refined the patent also to be so that you can let the sensor be the guide, so to say. So if you have a multi-beam echo sounder that has multi-beam echo sounder that has a kind of fan-shaped coverage, and the sea depth varies, your width of the sensor will vary.
Will vary indeed.
So you can then use that, and you would like maybe to keep maybe 10 or 20% overlap of those sensors. Then the formation separation is automatically varied to maintain that optimal overlap that you wish. Nice. So that's a refinement of that patent.
Very interesting. And can similar technology be used, for example, in search and rescue operations to locate somebody that fell overboard or something similar?
Yeah, I would generally guess so. It depends if it's underwater or on the water, but that has to do with the observation angle. You need to find something, but it's a general technology that could be used for whatever you find it suitable for.
Indeed. I've seen that it's quite fast, 35 knots. Why do you need 35 knots for data acquisition?
No, it's completely meaningless. It's for data acquisition usually 5 knots, 4 or 5 knots is usually standard. But the 35 knots is mainly because we at sometimes wanted to be on transfer from A to B a little bit faster. It also goes into the kind of multi-purpose nature of the vehicle that we, for example, if we were about to do some kind of patrolling or something like that, we would probably need that speed.
Yeah, makes sense.
So for surveying a pure survey vessel, I would think would be 15 knots would be sufficient.
And what type of sensors or payloads you can equip this machine with? Because it seems quite flexible, the platform. So I guess a lot of things you can hook up onto it.
Yeah, in general, the payload room is about 1 cubic meter in volume, and it has a moon pool with a elevator mechanism through the hull. So any kind of typical oceanographic sensor, sonar systems I just spoke about, can be attached to it. Also, there will be a version coming here now with also towing capabilities, so kind of winch on also to be able to drag tow bodies, etc.
Yeah, and you can also custom made this for the client. It's quite flexible, right?
It's always some kind of custom thing on the top. There's we try to stand as much as we can, but we also need to understand that the standard is custom in a way, and be able to do that.
Interesting. This vehicle is controlled by vehicle control station. Can you tell us what is it and how do you actually control the Mariner?
Yeah, so what we have, there's many names for this, but we call it the vehicle control station, which is literally a software that we try to put on a PC or of course on a computer with a screen that is as wide as possible. And it's a fully own developed and own software product. So basic components is that we of course have the navigation map where we it's a sea chart. We have a lot of vessel information, typically navigation info. We also have a lot of engine info, a lot of sensor info, lanterns on off, etc. And also, of course, becoming more importantly is that you also have some situational awareness monitoring on it. That will be, of course, we have radar, we have cameras. We are, cameras are in 2 specters, daylight and infrared. AIS, of course, is mandatory. Yeah. And so that component is also important. Mainly, which we are operating in 2 modes, and the remote control version is something we just use for launching it and recovering the vessel. So just a few minutes. And
then it's directly controlled by human, right? And then you engage some more autonomous mode or waypoints or...
Basically, usually a waypoint mode, pre-programmed or reprogrammable mode. And we also have certain collision avoidance aiding systems, and I'm very picky on that. I call it collision avoidance aiding because I don't think the legislation or the insurances or the world in general is not ready for leaving those robots out there without any supervision.
Yeah. So these are basically the autonomous and automatic capabilities. It can follow waypoints. It can aid into avoiding all kinds of obstacles. And what is the range that you can control the vehicle from? Like, do you need to be in the field of view above the horizon? How far?
Slightly behind the horizon, but it's theoretically we could sail worldwide via you could say using the Iridium or satellite communication.
Indeed.
But that wouldn't give you the sufficient situational awareness that we think you should have. In that way, you need something that has a bandwidth enough to be to kind of transmit a stable radar picture, a stable camera view, etc. And that will be that you need typically a link system in the gigahertz band, range, 2.4 typically or higher. On the Mariner, we have a standard high bandwidth radio system there, which gives you about 15 kilometers maximum range.
All right.
We could go longer if we have it's a little bit the size of your wallet also. That's this.
Anything is possible.
Yeah, in many ways.
How is the vehicle launched? Is it just lowered with a ship's crane and you recover it in the same way, right? It doesn't have some sort of special launch system.
We could do that, but also using a conventional crane. But it's not as elegant. So we have also what we use mostly is now a purpose-made docking cradle.
Okay.
Which has also the which is I think a little bit important these days, is that it also is something that we could hook onto an existing davit or an existing ship crane. You can foresee in the future big ships will be built around hosting a USV. The situation today is that they are not. And with at least the downturn in the offshore industry, it's not likely going to have a boom of new boats built either.
Yeah,
so
that's true.
it's we that have to adapt to what's there. And then it's if the docking cradle that we have is adaptable in a conventional boat davit, and it's really a semi-submerged cradle that we lower into the sea, have the USV to sail into it, and then we just winch the cradle a little bit upwards, and then the USV locks, and then we take it up.
Yeah, sounds logical. It also helps you to do the launching and recovery in a little bit more rougher sea state with this system.
Yeah, exactly.
All right. Okay, that was a lot of info about flagship Mariner. What about little Otter?
Yeah, the Otter, it's... we weren't the first to enter that market of smaller USVs like this, but we saw that there was a tempting commercial side of it that was probably one of the more important factors for us to enter that market. We saw that by creating a smaller, easier accessible unmanned surface vehicle, we could get a little bit closer to what we see on consumer drones, multicopters today.
All right.
What I was really after with the Otter is I saw that with the Mariner, as I said, it's always gets very custom. It's long processes to get the projects anchored with the user. It's big things usually. It takes a lot of time. With the Otter, we have, as we in a way forecasted, we see a lot more a quicker turnover from, you can say, we show the product till the decision is made until we actually are delivering the product to the end user. And I think for us, it was, as a company, it was very important to get the commercial wheel to start spinning a little bit faster.
Yeah, I get it.
And by having a more, you could say, bread and butter product, lower priced, of course, also, that momentum is created, and the structures that we also need to have in place to sell, for example, the Mariner, is now in taking place.
Yeah. And how big is Otter? It's around 2 meters, right? 2 meters long.
Exactly 2 meters.
All right. And it's battery powered.
It's battery powered, so we have lithium polymer based battery packs in the pontoons on the side.
All right.
Giving it a range of, an endurance of about 15 hours, which is, I think, in that size, it's a market leader in terms of endurance.
Very impressive. And it uses the same vehicle control station as the Mariner, I assume.
Basically, yes. In a little bit differently wrapped, but the same software goes on them both. Yes.
Mm-hmm. And besides in-house developed vehicles, you also offer conversion kits So that also sounds very interesting and with a lot of potential applications. Could you tell us more, like what type of hulls are usually can be converted with this kit of yours?
Yeah, in general, we could convert anything. Any propulsion vehicle can be converted with this system, and I think also you can say that what we define as our core technology lies very much in the conversion kit, in lack of a better name so far. Because I usually say that the combination of the vehicle control station, which is the software where the operator controls or monitors, linked together with communication systems to what we call the onboard systems, which is the boat-mounted parts, is our core technology. And we saw that, for example, a lot of these, for example, the different survey companies were very curious about unmanned boats, but
like
maybe they hold...
like retrofitting their current boats with some autonomous unmanned capabilities.
Yeah, then the risk wasn't that big for them to move on, because you could say that an average, I don't know, maybe a new boat in itself is an investment of maybe $200,000. The Mariner is also a boat. So in a way, it could, if you already had taken that investment, you could actually take the conversion kit and move into the unmanned era. You could then use the vessel sometimes unmanned, but you could still go back to the old way of using it manned. So in a way, it's I think it helps the clients to kind of a little bit. They feel it's a little bit less risky, and they feel it's a little bit, of course, definitely also a cheaper way of getting experience into unmanned systems.
Yeah, it lowers the bar for entering this new era, as you said. How is the integration done? What is the level of integration, and is it a lot of work? Is it how is it achieved?
No, if it's well planned, it can go in a few days. Mechanically, we have a couple of boxes, more like shoebox sized boxes, that we attached to your existing propulsion and steering systems in the boat. And the other side of the box is usually connected with the sensors and the communication systems that are usually located in the mast or on the wheelhouse roof, or the roof of the wheelhouse. Sorry. Yeah, and sometimes we also try to reuse some of the sensors that are. If you have a good navigation system, for example, we can reuse that one.
Very interesting. Can you give me an example of like a client that converted his boat to your platform?
I think an excellent example of what I just described for the kind of marketing mechanism is probably the German part of Fugro in Bremen that had. Not exactly a design award-winning vessel, but they were ambitious and curious about seeing how this unmanned capabilities might work for them, and they were had faith in this, and we converted their boat into this kind of unmanned dual use. I call it. It's you can still be manned, but you can also be unmanned, as you wish.
Yeah, that's. I hope a lot more interest will come also from for this, definitely.
Yep.
And Now, when you have also humans and unmanned systems, how behind is the legislation compared to technology? I mean, you described all kinds of capabilities that nowadays technology can offer in the maritime, and where is legislation in all of this, in your opinion?
I think in many ways legislations are where they should be, behind. Because you can't really demand that the legislators should be ahead of technology. That would be
a weird position, to be honest.
That would be a weird position. I think the world would have been where it is today if that has been the case. So I think we're, especially in the North European countries, starting in Norway, you have, of course, Finland, very active. You have UK being very active. You have Germany. You have the Benelux countries being very actively into autonomous ships and boats, are pushing this very nicely right now, the legislation part, I think. Mm-hmm. We also know that IMO have now started very seriously into this work. And I think there is a lot of political momentum behind this work now, especially from those flag states I just mentioned. We know that Asia is coming pretty heavily, as always. And so I think as of now we don't see this as if you start with our Otter, for example, it can't really do much harm. If you go for a Mariner, yes, it can do more harm. The basic thing you always need to do in I'm sure that's going to come also when the legislation is there, is that you need to do your own risk analysis.
Of course.
Being structured or...
sorry. Wanted to ask you, as on a more practical level, like I agree with you that there's a lot of work being done on a national level. But what about international level? Like, could you sail one of your SUVs from Norway to, let's say, UK?
Not at the moment legally. At least if it was what we could define as an unmanned ship. So you have a regulation that allows you to sail within the flag state, so to say. That would be probably within a 12 nautical mile zone, or but of course there are many groups of unmanned surface vehicles. We know that, for example, small long endurance unmanned surface vehicles, typically in the range of 2, 3, 4 or 5 meters, have crossed oceans and definitely crossed borders. And this is also, in a way,
there are also competitions in this, crossing the Atlantic, and
they're not being arrested so far. So again, it's all about common sense and your risk analysis. But for unmanned ships, which is this is not allowed as of now. But as I said, IMO are working seriously on it.
Yeah, it will get there. It just takes some time. Yeah. And we can start slowly wrapping up. But before we do, I would just like to ask you, what's your vision of future of USVs? Because right now we see a lot of applications for data collection, but robotic systems can do much more. And which parts of industry are you expecting to see the biggest adoption of unmanned and autonomous?
I think definitely, as you said, also indicated here, there are, if you look at any big city or harbor or something you see in front, most of the boats that you're seeing is used for some kind of transportation of cargo or people. So just by taking a statistics of what's out there today, transportation is going to be the big growth sector. But of course, there's going to be also a nice growth in platforms for, you can say, data acquisition, which is the segment that we have been working in so far. But we, of course, also see that our core technology can be used for really controlling any boat. or ship for that case.
Do we need some, or is the future coming with some sort of a countrywide or international platform for data exchange? Because if we want to have all of these drones hooked up together, they need to have a common protocol to speak on, right?
Could be. Of course, they could be equipped with basic AIS systems that is not necessarily mandatory for unmanned ships, but they could be.
Yeah, but that's like very low fidelity. Something more is needed.
That could well be, and I am sure somebody's looking into it already.
All right. Interesting future ahead of us, for sure.
Yeah, no doubt, and I think a few of us had surface vehicles have lagged definitely a lot behind the flying cousins, the UAVs, and 5 years ago I would never have foreseen that the change should come. I think for our national sector in Norway, I think we were a little bit too drugged maybe on the oil money, and and maybe that blocked also sometime innovation, and then the whole country in a way had to start looking into other arenas, and luckily for us, autonomous ships came up to be the one of the really politically prioritized sectors, and so yeah, and that happened fast in 14-15.
Yeah, and the things are heating up. More and more companies are popping up, and there's some serious competition happening, and I think we're on a very good track. It took a while, but yeah, it's heating up.
Yeah, competition is always good.
Indeed. And for the end, what are you trying to accomplish in the next few years? Like, what's your in which direction you want to go?
I think we need to standardize on a few platforms, as we are in a way doing with the Mariner and the Otter as a couple of standard platforms that is more like turnkey platforms. Could be more, and also focus very much on keeping ahead and keeping the lead that I think in many ways we have also in maritime control engineering, maritime autonomy system. And of course, as I said, higher degrees of autonomy, more capabilities for collision avoidance, or etc., will be crucial. I think we're in a very good spot, but we need to keep working hard to keep the lead.
Great. Yeah, I wish you all the best for the future for you and your business.
It's been great participating in your podcast here, and I wish your portal a good future.
Yeah, thanks a lot, and likewise. And
very much.
Thanks for this opportunity. Bye,
very well.
Vegard.
Thank you very much.
Everybody, thank you so much for listening, and I really hope you enjoyed this one. If you haven't already, be sure to follow us on Twitter. Our handle is @AutonomousShips. You will also find us on Spotify, YouTube, and LinkedIn, so go ahead and check it out. It would mean a world to me if you would share this episode with your friends and colleagues on social media. So please do so. Share it and let me know what you think about it. And that's about it. Until next time, my friends, take care.